Hello everyone, let's talk about this Leetcode problem called add digits. Although it's an easy problem, but this problem has a very interesting optimal solution. So this video aims for people who have some background in computer programming, but didn't dive that deep into mathematical concepts like number theory. So if this is your first time seeing this problem, I can guarantee you that you will be amazed by the optimal solution. So the problem is like this. Given the integer num, repeatedly add all its digits until the result has only one digit, and then return it. For example, if we are given the number like 38, then the process is like this. Because 38 has two digits, then we add these two digits, like 3 plus 8, we get 11. 11 still have two digits, so we add 1 plus 1, and then we get 2. Then, since 2 is the only has one digit, then we return 2 as a result. The second example is like this. If we are given the num as 0, then we just return 0 directly, because 0 is already one digit, right? So let me give you two more examples here. The first example is like 1, 2, 3, 4. Then we add these 4 digits, we get 10. And then we add it again, we get 1, right? Another example is like 4, 4, 4, 4. Then we add these 4 digits, we get 16. And then we add it again, we get 7, right? So this is basically what the question is all about. But the interesting part is that this question actually has an O1 solution. It means that you can achieve the result without any loop or recursion. And this part is very interesting. So in this video, I assume you have the basic knowledge of programming, such as you know what is if and else, you know what is a while loop, you know what is a for loop, and then you know the concept of common complexity. You also have the high school level of mathematics. Then you are good to go. So now you can pause the video and try to think about the optimal solution yourself. Then I will explain it later. Alright, how is it? Let me explain the optimal solution to you now. First, we need to know that the output can only be the unit digit, which means it can only be 0, 1, 2 until 9, right? And let me tell you this, if the output is among 1, 2 until 8, this can be solved within one line of code. It sounds crazy, right? But it's possible. So how can we do this? It's very simple. We just return num mod 9. It means that we divide it by 9 and we get the remainder. So let me show you this crazy solution. Let's try the test case that they provide us, which is 38. Then we run. The result here is 2, and it's as expected. So let's try the example that I give you. It's 1, 2, 3, 4, and the result should be 1, right? As you see, it's 1 here, and it's as expected. It's the same as expected. So let me try another one. It's 4, 4, 4, 4. And it's 7 here, as expected. You can try it yourself. You just, if the result is among 1 until 8, you can just mod 9 and then get the result. You will be the same. Okay. And actually the 0 and 9 situation is just the special case of this mod 9 solution. So let me explain the mathematical parts behind this solution. Okay, now, before we explain the solution, we need to learn the concepts of theory of congruence, or you may have heard the name, modular arithmetic. So the starting point is like this. We have A is congruent to B mod N, and the symbol here means congruent. So the informal definition is like this. So A and B have the same remainder when they are both divided by N. For example, 5 is congruent to 2 mod 3. Why is that? 5 divided by 3, the remainder is 2. And 2 divided by 3, the remainder is also 2. So another example is like 15 is congruent to 18 mod 3. Because 15 divided by 3, the remainder is 0. And 18 divided by 3, the remainder is also 0, right? And if you learn computer programming, you probably deal with mod 2 before. And we use mod 2 to decide whether the number is even or odd. And in mod 2, you usually have two values, 0 and 1. And in mod 3, you have three values, 0, 1, and 2, right? And if you consider mod n, the possible value is 0, 1, and until minus 1. Oh, sorry. Until n minus 1. So this actually means when you consider mod n, every integer is congruent to one of this. For example, like 15 is congruent to 18, congruent to 21, congruent to 24, congruent to 0 mod 3. So another example is that a is congruent to 5 is congruent to 2 mod 3. So every integer can be congruent to one of these sets when you're considering mod n. Okay, now let's take a look at the formal definition here. Let n be a fixed positive integer and blah blah blah. The key point here is that n divides a minus b, which means a minus b is equals to kn for some integer k. So this is the most important part in this definition. Because from this definition, we can have the following properties. Okay, this looks a lot, but it's actually very easy to understand. Let's take part E as an example here. We know A is congruent to B mod n, and that means A minus B is equal to Km for some K. Okay, I just use dot 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 here. And then, so it's very easy, like A plus C minus B plus C is equals to A minus B is equals to Kn. So we already have A plus C is congruent to B plus C mod n. And this is the first part. And for the second part, you know we have A minus B equals to Kn. You just multiply both sides by C. So we got AC minus BC equals to KCN. And you just put a little bracket here. Then we already proved AC is congruent to BC mod n. So now we know how to prove the properties. Let's see how we can use the properties in the actual calculations. Let's take part D as an example here. Suppose we have A times 11 is congruent to something mod 3. And then how to use part D? We have A is congruent to 2 mod 3. And then 11 is also congruent to 2 mod 3. So we have A times 11 is congruent to 2 times 2 is congruent to 4 is congruent to 1 mod 3. I know we can calculate directly like 88 is congruent to 1 mod 3. But what I want to show you is that when you have multiplication in modular arithmetic, you can just mod them separately and then times them together. What I'm saying is that A times B mod n is actually equals to A mod n times B mod n, and then the whole thing mod n. Okay? So this is very useful properties. If you already understand this, let's also check the addition. So if we have A plus 11 is congruent to something mod 3, we know A is congruent to 2 mod 3. I will ignore the mod 3 here. And 11 is congruent to 2 mod 3 as well. Then A plus 11 is congruent to 2 plus 2 is congruent to 4 is congruent to 1 mod 3. Right, so this is still the part D for the addition. And then let's see the last property, which is the part F. We have, suppose like 10 is congruent to 1 mod 9. Then 10 to the power of 4 is congruent to 1 to the power of 4 is congruent to 1 mod 9. Right? So similar, we also have 5 is congruent to 2 mod 3. Then 5 to the power of 7 is congruent to 2 to the power of 7 log 3. So now we got all the tools that we need for the original question. Suppose we have the input 1, 2, 3, 4. Then what is 1, 2, 3, 4 in the decimal form? 1, 2, 3, 4 is actually 1 times 10 to the power of 3 plus 2 times 10 to the power of 2 plus 3 times 10 to the power of 1 plus 4 times 10 to the power of 0. Then what if we consider the mod 9 here? If we mod 9, then all the things that are related with 10 will become 1, right? Then this will become 1 plus 2 plus 3 plus 4. And this is already sum of digits. And we know this is 10. And because we are considering mod 9, it will become 1, right? So this is the reason why this method works. So now let's take another example in case you didn't fully get it. Let's say n is equal to 24787, and in decimal we know this is equal to 2 times 10 to the power of 4 plus 4 times 10 to the power of 3 plus 7 times 10 to the power of 2 plus 8 times 10 to the power of 1 plus 7 times 10 to the power of 0. So we know under mod 9, all the things that relate to 10 will go to 1, will become 1. And we know this is already 1. So this thing will congruent to 2 times 1 plus 4 times 1 plus 7 times 1 plus 8 times 1 plus 7 times 1 again. And then it's congruent to 2 plus 4 plus 7 plus 8 plus 7. And this will be 28, is it? Let me double check. Yeah, it's 28. And then you see this is already sum of digits, right? And then under mod 9, this is actually again 2 times 10 plus 8 times 10 to the power of 0. And again it becomes 2 plus 8, and it becomes 10, and it becomes 1. Oh, sorry, it becomes 1 here under mod 9. So this is why it's so amazing. This method is like, you see, there are 2 sum of digits here. So basically when you take mod 9, the operation is done automatically, like from the math perspective. So this is the beauty of it. Then let's go back to the programming part. Okay, now I'm sure you understand the theory behind this solution. Let's talk about the cases when the output should be 0 and 9. So, if the sum of digits should be 9, for example, like 54, the output should be 9, right? And then, if we mod by 9, then we will get 0, right? So, basically, when the output is 0 or 9, in this solution, it will become 0. So we just need to consider these 2 cases. The first case here is when the output should be 0. So it happens only when the input is also 0. And in this case, we can just return 0. We can change the input to num here. Right? After we filter out this case, if the num mod 9 is equals to 0, then we just return 9. Right? So we just add these 2 conditions, and then this solution is completed. Okay? And actually we can just combine these 2 lines here with the ternary operator. So we return 9 if num mod 9 is equal to 0. Else we just return num mod 9. Alright? We can further simplify this solution and make it really become a one-line solution. But how? Let me give you some hints. So we're actually dealing with one condition here. We only return 0 if num is equal to 0. Then, how can we combine this line here into this parenthesis? So, try to think about how can we use the num and the operation mod9 and then make it return the result we want into this parenthesis. Okay? Now you can pause the video and try to think about yourself, and then I will teach you later. Okay, the key point here is that we just shift it by 1, and then mod 9, and then plus 1 back. And this will become the one-line solution. So it's very clean, but it's not that readable at the first sight. So this is the final solution of this problem. Thank you for watching this video. I hope you enjoyed it. And this is actually my first YouTube video. So if you like it, please like and subscribe. It really encouraged me to make more videos like this. And if you have any suggestions, please let me know in the comment section. Okay, thank you and see you next time.